Good afternoon to all. Previous lecture
Good
is over.
afternoon, sir. Yes, over.
Okay. Strength is so less. I think now 38. Okay. We will start. See, in last lecture we have discussed related to the various instruction sets, and before actual starting the instruction set, we will go with some guidelines provided by Microchip, that is a manufacturer of PIC microcontroller or PIC series of microcontroller. Okay. So based on these guidelines, we have to proceed further. So before going for instruction, we will go first or summarize some guidelines given from Microchip, and then we will go for the instructions. So see, the guidelines related to the how to write instruction or specify the instruction like that. Okay. So when we are discussing about the ALP programming for my PIC microcontroller, generally we consider these following points. Some points are not mandatory as per your choice. Okay, see, the first point mentioned is that write instruction mnemonics in lowercase, that is add, move, or whatever the mnemonics are there. So these are written in lowercase, like move WF is the instruction part. Okay, main, and what operation is need to be performed is defined in mnemonics, and after that operands are there. Okay, so in this case it is generally suggested that mnemonics should be written in the lowercase, but if you write in uppercase, no problem. There will be no error generated while building an ALP for PIC microcontrollers. Okay, after that write the special register names, that is SFRs, RAM variable names, and bit names in uppercase, like W register. Okay, after that some status, option, pecan, like that. So these registers names should be written in capital letters. Okay, it is suggested that it is not an mandatory task, but mostly we prefer or follow these guidelines, that is instructions given from Microchip. Okay, third one is write instructions and subroutine labels in mixed case. This is also not an mandatory, but prefer for these type of mentioning the labels. Okay, so either if we write a loop here. Okay, so next, some of the instructions we will see first. It is not an mandatory, I already tell you. Okay, but we have to prefer. Preference is given, like this is the reference format or reference for us, and with the help of these instructions we will proceed further for the writing an ALP or designing an ALP. Okay, so the instruction set for PIC16F consists of only 35 instructions, as it consists of RISC architecture. So instructions are reduced, and that too only 35 instructions are sufficient for writing an ALP for various application. Okay. After that, some of these instructions are byte oriented instructions and some are bit oriented, that is carry flag, suppose timer flag, or external interrupt is there. So these are the BOR is there. Okay, so these are the bit oriented, and byte oriented instructions like W register, FSR, whatever FSR is there, int con is there. So these are the byte, means 8-bit completely we have to define. Okay, or some ports like that. Ports may be used as a bit oriented operation or byte oriented operation. Okay, so according to that, we have to go further. As per your requirement, you are able to write either in bit type or byte type. That is specification or writing an instruction for your requirement purpose. Okay. So after that, if we go with the byte oriented instructions, that requires two parameters, that is source and destination. Okay. For example, if we consider move f, and in case of f of w, here w is your working register and small f or capital F, whatever you discuss related to that. These are the some file registers. They are not having predefined memory locations, but after defining it, we further use or consider that particular file register as that memory pointer only. Like if we define f is equal to 50h or FSR is 50h. So in that case, in that program 50h allocated for that F or FSR or F1 if you mention the name. Okay, so we will go with that address and that particular register name. But in case of some SFRs like port A, B, C, D, E, after that timer 0, timer 1, or some intcon, POR, PCON. So these are the specific located registers. They are not interchange their memory locations for different programs. Means simply they are used for that particular locations only, and that's why we have already discussed that in case of RAM memory allocation or RAM memory calculation, that is data memory, program memory and data memory. In that, out of 512 bytes, total available bytes with the PIC 16F, user is able to modify or edit or use only 368 bytes of the memory locations. That is, we are considering 368 byte RAM, and rest of the memory locations are reserved for the application or specific functions given by that SFR, or multiple SFRs are there. So we are not able to modify the contents or cannot use for general applications. That's why we did some calculation related to adding 16 bytes, replication of bytes. Okay, additional 32 bytes are there. So how the 368 count comes? Okay, we know very well. So in this case here, the locations associated locations associated for the specific, suppose port A or some intcon or some timer or watchdog timer, they are fixed and predefined. And in case of file registers, we consider again a file register only. We are talking about file register. So these are generally considered as a blank registers like SBUF. We have seen SBUF register in 8051 microcontroller. So as per requirement, we use the various file registers as per our applications. Okay, and next point is f of w parameter is destination of the result of operation. It should be replaced by. Okay, so in case of this, the meaning is that after execution of an instruction, add a comma f, whatever the contents are there, and in case of 8051, the result of ALU operation is always stored in accumulator. Okay, but in case of PIC microcontroller, if we want to store the result of that particular ALU operation in file register, then it is also possible in the same instruction itself. That is, here a instruction specifies which address or which register is used or selected as a destination register. Okay, so instead of using only W register, like similar to the accumulator used in 8051, we are able to modify the destination register, either use W, either use file register, or any of the register used in that particular instruction. So we will go by setting the bit either 0, either 1. So then we are able or capable to modify or change the destination register in the same instruction itself. It is not mandatory to write again separate instruction to copy the content from working register into the some file registers. Okay, so this is the facility, that is F is the destination is to be the source register, and W if the destination is to be the working register. F कधी वापरायचं आहे, जर अदर दॅन W रजिस्टर जर आपण यूज करत असेल डेस्टिनेशन म्हणून, तर कॅपिटल F लेटर वापरायचं आहे. अँड capital W is used for using working register as a destination register. This is one method. Again, another method is there, defining the bit D. D bit comes later, we will see. So D varies from 0 and 1 only. If it is 0, then the result of an ALU operation is stored in file register. If it is 1, then result of an result of an ALU operation is stored in W. Okay, we will see later. See, after that, if you see in the next instruction, that is bit oriented instructions. Related to bit oriented instructions, like suppose example is BTFSC, bit test and skip if carry. Okay, carry is set. So F is here file register and B is your bit from 0 to 7. So B range is from 0 to 7. That is, we are generally using 8-bit register. So it will vary from D0 to D7. So the meaning of B is that any number from 0 to 7, that is any particular bit we are using for this purpose. Okay. And after that, see, some word list is there. So specific words are used, like F is used for assigning or mentioning some memory location, that is file register. W is your working register. B is a bit position in F register, means file register. So it varies from 0 to 7. And here D, destination bit, whether it is 0 or 1. So based on that particular status of D bit, your result may be stored in file register or in W register. Default status is W register. If you want to change the destination register, then you are able to change with the help of assigning the bit to the D register. Next word list is label. Generally, we use any name for the label, no problem. But if you want to use the particular name continuing with that, that is label, group of characters. Okay. Then TOS, top of the stack. So it will mention that top level of the stack. So whatever the empty locations are available, we will find out with the help of this TOS. Option, it is specifying whether the particular status of D bit, that is 0 or 1, and next is less than, greater than, in, that is in between. The range is defined in between. Suppose we are using bit 0 to bit 2. So here in these brackets you mention 0:2. So all these bits, or 0 to 5. So 0, 1, 2, 3, 4, 5, instead of writing like this, you should mention only in between these two uh, symbols, that is 0:5 or whatever 0:4, like that. So these are the some word lists. After that we will go for the instruction set, but you write for this, that is guidelines from microchip for writing and ALE. Okay, so these are not asked in your exam, but you should write it as it is necessary while writing an instructions for various applications. त्यावेळी आपल्याला लक्षात यायला पाहिजे की कसं लिहायचे आहे इन्स्ट्रक्शन, त्याचे बीट्स काय आहेत, डी कधी वापरायचे, बी कधी वापरायचे, बीट नंबर कसा डिफाईन करायचा आहे फॉर दॅट पर्पज. ओके, जस्ट टेक अ नोट.
Completed, sir.
Okay, we'll go for next. Here, these are the guidelines, not and mandatory things or rules for writing an ALP. As the name itself, guidelines, you may refer or you may vary with some characters or some different structures. Like instead of writing capital letters, you may write for small letters. Instead of small, you may write for capitals. Instead of assigning mixed label, you may assign the same characters, that is lowercase only, uppercase only, like that.
Completed, sir.
Okay. Write down some word list that is generally used letters in ALP instructions. Completed?
No, sir. Completed, sir.
Okay. So these are the some guidelines given from microchip. After that, we go for actual instructions. As we have seen, the instructions are divided in these categories: data transfer, ALU, bit oriented, and program flow control. And some remaining instructions are in the category of other instructions. Okay. So we go first, data transfer instructions. So in case of data transfer, the meaning is same as we have considered the instructions in 8051. That is, data transfer instructions means we are transferring the content of source register into the destination register by keeping content of source register as it is. We cannot remove the content of source register if we perform an data transfer instruction. Okay. So see, when we use to transfer the content from one register to another register, then original content of the source remains as it is in case of 8051 also, and in case of PIC16 microcontroller also. So in this category C, following instructions are available or comes under this category of data transfer instruction. So in this case, if we see the first mnemonic like move LW and K. Okay. So here move and L consecutively, and also W is also there. So no space between move, L and W. So we have to write it in consecutive manner, or no space is given in the each character. Okay. So write successively MOV LW. So as we define that L is literal value or literal number, where it is K means your actual value. K is a immediate value, constant value, and it will be indicated by letter L. So L literal value or literal number. So move LWK means the content K, whatever 20H is there, 40H is there, 02H is there, whatever. Okay, actual data will be copied into W register. The meaning is that content K will be copied into W register here. Okay, so W is your destination register in this instruction. K's content transferred to W, and we considering K is nothing but literal number or literal value. So we write the instruction move LW space K. So move the constant to W. Constant means number. Whatever number is there, it will consider as a constant number. That is symbolic representation is K tends to W. So K is loaded into W. One cycle is required. Okay. And flags are not affected here. So flags affection is also mentioned. So no flags are affected. After that, move WFF. So here reverse procedure is there. Move MOV WF. Okay. Move WF. And here actual file register. Here we mention the file register or a memory location. That is move the content of W into the F. F means file register. And in symbolic representation like this, W tends to F. So whatever the contents belonging to W, they are simply copied or loaded into the F register. So here also flags are not affected. After that, move F comma D. Move F comma D. So in that case, whatever the contents are available in file register, see here, F is your file register, but as we mentioned, the D is a destination bit here. D is destination bit. It may be 0, it may be 1. So move the content of file register based on or depends on the status of D. Okay, so F tends to D means if it is 0 or 1. If it is 0, then it will be moved to the file, and if it is 1, then it will automatically copied into the W register. So another method to copy the content in W like this, if we have known that the constant number 02, 04, 20 need to be copied into W, then we go for this first instruction. If we don't know the number stored in that particular memory location, suppose 100H is the memory location, and from 100H we want to store the content into the W or some another file register. In that case, we go for this instruction. Majorly, we go for content loaded in memory location pointed by this F into the W register by specifying this D. Okay. So these are the some direct loading instruction, that is copying the content. Here 0 flag may be affected if we copy the 0 into the W register. Okay. Here D may be 0, may be 1. So based on that, depends on the position of D, it may affect the working register, content of working register. So in this case, 0 flag will be affected for this instruction. Okay. After that, next instruction is CLRW. If you want to clear the content of working register, then go with this CLRW. No space between CLR and W. Huh? As we have seen CLRC. Okay, in earlier case, but here no space. CLRW, clear the W content, that is 0 tends to W, and 0 flag will be affected. And same case for file register, CLRF, F for file register. So CLRF, this is your file register F. Whatever the number is there, it may tends to the memory location or points to the memory location. So clear file. File means file register. So 0 tends to F, 0 flag may be affected. All the instructions are executed in single machine cycle. Okay. After that, swap, SWAPF, FD. So whatever the contents belonging to that particular file register, they are swapped in between, that is lower nibble and higher nibble. If you've seen that, swap nibbles in F. F means file register. That is 0 to 3 your lower nibble and 4 to 7 is your higher nibble in the same register. So it will be reflected like this. Lower nibble becomes higher nibble and higher nibble becomes lower nibble. So if you've seen this, his range is mentioned that 4 to 7 and 0 to 3. So it will becomes 0 to 3 and 4 to 7. So it will be altered or exchanged, swapped together in nibbles. And if it is specifically, if D is mentioned, in that case again, it will loaded into the W register also. It is possible to load this swapped nibbles into W register directly. So these are the some instructions used for data transfer. Okay. बघा काय डाऊट आहे का? If you have any query, please ask. You keep in mind that L is always representing a constant number and small f representing always a file register, that is memory pointer. If not, then start writing. Draw this table. Meanwhile, give me attendance. Roll call 1. Roll number 1, absent. 2,
Yes, sir.
3,
Present, sir.
4, 4,
Present, sir.
5.
Present, sir.
Yes, 4 is present. 5,
Yes, sir.
6, 6, 7,
Present, sir.
8, 8, absent. 9,
Yes, sir.
10,
Present, sir.
11,
Present, sir.
12, 12, 13,
Present, sir.
13,
Present, sir.
14. Okay, 14,
Present, sir.
15,
Present, sir.
16,
Present, sir.
17,
Present, sir.
18,
Present, sir.
19,
Present, sir.
20,
Present.
21, 22, 22, 23,
Present.
24,
Present, sir.
25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28, 28, 29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32,
Present, sir.
33,
Present, sir.
34,
Yes, sir.
35,
Present.
36,
Present, sir.
37, 37, 38, 38, Rishikesh, I think someone, 39,
Present, sir.
39,
Present.
hello, who is this?
Present, sir.
Okay, good. 40, 40, Kaustub, 41, 42,
Present.
43, 43, absent, 44, absent, 45, 46, 47, absent, 48, 49,
Present, sir.
okay, 50,
Present, sir.
51, 51, absent, 52, 53,
Present.
okay, 54, 54, मुळे ना, absent, 55, 56, Patel, 56, 57, Patil, 57,
Yes, sir.
58,
Yes, sir.
okay,
Yes,
58,
sir. Yes, sir.
Patil, your attendance is marked as present. Next number, 58, 59, Pawar,
Present, sir.
60,
Present,
okay,
sir.
61, Giridhar, 61, 62, 63,
Yes, sir.
64, Akshay, 65, Prathamesh, 65, 66, 67,
Present, sir.
68,
Yes, sir.
69.
Yes, sir.
Okay. Have you completed this?
Yes, sir.
Okay. So after data transfer, we go for next. That is some information is provided. So it is not necessary, or if you want to write it, no problem. That is a constant being written in W, like ELW. So meaning for these instructions, it is mentioned. So it is not actually required. as we have discussed. Okay, so we go directly, or if you want to write, you write from the instructions. Take a screenshot and write down after that. Okay. The next. So next type is arithmetic and logical instructions. So whenever we perform, that is CPU will perform an ALU operation, in that case, we need to use these instructions, that is add, subtract, and or XOR, increment, decrement, rotate, and complement. Okay. So in this case, instruction like multiplication, MUL, and division like DIV are not present in PIC 16F. Multiplication is available in PIC 18F, but in case of PIC 16F, it is not available. So there is another method to perform the multiplication. We will see later, but here only addition and subtraction instructions are available in 16F. And if we consider the 18F, then multiplication instruction is also available. So like earlier case, that is 8051, to perform the various arithmetic operations as well as logical operations, we requires two operands. One mostly we prefer for W, and another operand is file register or some constant number. Okay, so in this case, if we consider sequentially, that is first instruction, that is add LW and K. Here, as we have seen, the L stands for literal and K is your constant number, constant value. So K contents, whatever the contents belongs to K, as a representing, it is mentioned K, but it is not K, like 20H, 04H, 30H, like that, or 50H. So here, whatever the contents are available in W register, they are simply added with the constant K, or the value available in W is added with value in K, or K is the value we consider simply. Okay, add a constant value with W, and result is stored at W only. Okay, so next is add WF, that is we prefer or we go with the file register as it is mentioned F. Okay, and comma D. So if we mention the D here, that is D is equal to 1, in that case it belongs to that particular D status, whether it is 0 or 1. Okay, based on that situation or condition. So in this case, for the addition and subtraction, carry, digit carry, or zero flag may affected for addition and subtraction. So W plus F tends to D. D is 0 or 1. Based on that, it will store the result in either file register or W register. So similar to the addition, we go for the subtraction, that is SUB LW, then W minus K. The result will be stored at W. And second case with the D status, that is subtract W from F. Okay. So in that case, whatever the result is there, it will be copied into the status dependence. That is, if it is 0, D is equal to 0 or D is equal to 1. So based on that, our result will be stored or loaded. And all the above 4 instructions, all 3 flags, that is 0, carry, and digit carry, are affected, may affected, not always, may affected based on the result. Okay, and all these instructions again requires only one machine cycle. So you write for these 4. We will discuss logical instructions in next lecture. Okay, write down arithmetic and logical.
सर डायरेक्टली केलं म्हणजे जे डेटा ट्रान्सफरची instruction
If we want to continue in the same table, okay, so you continue, just mention one horizontal line, that is arithmetic instructions, arithmetic and logical instruction. Continue with the above, I think 6 instructions are there, na?
yes sir
Mention here 7 number, add, number 7, 8, 9, 10, like this. Okay. You may use the same table as it is, continuing with that. So no need to write the description and rest part, as you know, or after that while writing the instructions, you are much familiar with these instructions. And you mentioned that if d is equal to 0, result will be stored at w. And if d is equal to 1, result will be stored at f, that is file register, whatever the memory location or register is there. So in bracket, mention that if d is equal to 0, result is equal to w. And if d is equal to 1, result will be at f. Or in here you mention that d. It is mentioned at only d. So you write in bracket here after d. If d is equal to 0, result is in w. And below that, if d is equal to 1, result is in f register. So the status
Excuse
of
me, sir.
yes.
So instruction number 3, subtract W from the constant. म्हणजे ते K minus W हवं होतं ना? का
Yes, yes,
W
yes. Sorry.
minus K?
Subtraction ला चुकलंय हे. याच्यातच हे झालंय. Right. You may go like this, whatever the mention here. K minus W, and result will be loaded in W itself. K minus W, and here W from F, F minus W, not W minus F. Make correction. Check, I think in data sheet also. Okay. If it is over, only 4 instructions you have to write, then you will leave the meeting.
Okay, sir.
Hello, sir.
Yes.
Sir, roll number 28 present, sir. Network issue, ma'am.
Okay.